The following table shows the annual salaries earned by 150 workers or employees. I have given you the salaries and the frequencies. Show this frequency table in the form of histogram. So this is a what kind of frequency table? You have classes, you have ranges. So this is a continuous frequency table. First what they are asking is, they are asking us to show this one in a histogram. Here I will mark 0, 1000, 2000, 3000, 4000 and 5000. Maybe 10, 20, 30, 40 and 50. So between 0 to 1000, 25 I have to show 25. Between 1000 to 2000, 35. In your exam you won't get to draw the histogram. Okay. Here I am drawing this for y'all to just to get an understanding of what we are going to learn next. Okay. From 2000 to 3000, 40. From 2000 to 3000, 40. And next 3000 to 5000, 50. So here what you have to understand, I hope you all can remember this. From 0 to 1000, the class size is 1000. Here also class size is 1000. Here also class size is 1000. But this class size is 2000. So you are considering two classes. So when you are drawing a histogram, what you have to understand, the height of the bar will not represent the frequency. Actually area is what will represent the frequency. Okay. So here if you take this particular scenario from 3000 to 5000, you have two classes. Okay. Then to show frequency of 50, you have to take height of only 25. You have to take a height of only 25 because as I said you clearly, in histogram area only will represent the frequency. So here you have one class, here you have another class, so you have two classes. Then your width is 2. Your width is 2. How much is your height? Height is 25. Height is 25. Then width is 2. Height is 25. Then what's the frequency? Frequency is 50. Now if you take this particular circumstance, your width is 1. Height is 25. Then here frequency 25. Here width is 1. Height is 35. So frequency is 35. Here width is 1. Height is 40. So frequency is 40. But here width is 2 because you have two classes. Then your height should be how much? To show a frequency of 50, you have to take a height of only 25. Then you can show a frequency of 50. So these are basic things that you might have studied in your school level, but in your this paper you will not get anything to draw histogram charts. Okay. So now let's move into the most important part which is relevant for us. Calculate the probability of a worker earning between 1000 to 2000. Then if I pick a person randomly, if I pick an employee randomly, what's the chance of that particular employee's salary being between 1000 to 2000? Then in total how many employees are there? 150 employees are there in total. Out of that, how many employees are there between 1000 to 2000? 35 employees are there. Then as a percentage, how much is that? You can take it as a percentage. If not, you can keep it as a decimal value also. 35 divided by 150 into 100, I am getting 23%. I am getting 23%. And next what I am asking, calculate the probability of a worker earning more than 2000. Earning more than 2000. Then you have 150 employees. How many of them are earning more than 2000? These two categories. That means 90. Then here I am getting a value of how much? 90 divided by 150. It is 0.6. 0.6 means as a percentage, how much is that? 60%. Then here we calculated what? We calculated the probability. So this is a very simple calculation, right? Now when I connect this, if I connect this for this particular histogram, okay, what you have to understand, if this entire histogram is 100%, if this entire this entire histogram is 100% area. Okay, I am asking you how much is the area, how much is the percentage people who are earning more than 2000. That means I am asking from here to here. Then out of in total, here see, in total you have 150 pieces. You are showing a frequency of 150. From here to here, how much percentage, how much you have? You have 90. Then 90 divided by 150 as a percentage, then this particular area will represent how much from your entire histogram? 60%. So simply what you have to understand, from the histogram we can find out the probabilities. Now again I am asking you, okay, what's the probability of an employee earning a salary less than 2000? Then less than 2000 means these two categories, right? These two categories. Okay, less than 2000 means these two categories. So I am asking what's the probability of, or what's the percentage of these two categories that I highlighted now. So let me take a different color, maybe red color. What's the percentage? Then what you have to understand, this entire histogram is 100%. Okay, so 150 employees are showing you 100%. Then I want to see this 25 and 35, how much is that? Then 25 plus 35, how many employees are earning less than 2000? 60 employees are earning. Then how much is 60 employees? That's what I want to find. Then how I can find it? 60 divided by 150 into 100%. So here 60 divided by 150 into 100, how many percent is showing that? 40%. 40%. That's what I said. So this red color area is showing you 40%, as we previously calculated. This blue color area is showing you a 60%. Less than 2000 40%, more than 2000 60%. So simply what I want to show you here, what I want to teach you here, from this histogram you can calculate the probability. So now what we are going to do is, we are going to get this learning for an advanced step, and we are going to find out much more complicated probabilities. But before moving into that, I want to teach you something called normal distribution. What is this normal distribution? The normal distribution is effectively a smooth out histogram with a very specific shape. Then here, if you look at this particular histogram, okay, it has several rectangles. But once you draw a histogram with lots of ranges, okay, it will be like this. You will have small, tiny, lots of histograms will be there. Tiny, lots of histograms will be there. Your histogram will have something like this. Okay. So if you smoothen it out, your histogram will look like a bell curve. It will look like a bell curve. If you smoothen it out, it will look like a bell curve, something like this. So using this bell curve only, now we are going to find the probabilities. But before finding the probabilities using the bell curve, certain things that you have to remember. What are the things that you have to remember is, as I said you, this entire area is 100%. This entire area is 100%. Okay, because you are dealing with probabilities, we can take percentages. And if you take this bell curve, another thing that you have to remember, it is symmetrical. So this entire area, if it is 100%, if it is symmetrical, I am asking how much is this particular part, A part? It is 50%. Symmetrical now. Then how much is this part? The right side part, the B part, it is 50%. Then do keep in your mind very important two things that I said you. From the bell curve, Once you smoothen out your histogram, you will get the bell curve. From the bell curve we can find the probability. You will understand it perfectly when we are doing the calculation, believe me guys. For the time being, just keep in your mind, this bell curve entire amount is 100%. It is symmetrical. One side is 50%, other side is 50%. And this particular point, it is your mean. Okay. And when we are doing a normal distribution calculation, we are assuming your mean equals mode equals median. That means your mean, mode, median, everything is same. It's a general assumption that we are making when we are doing a normal distribution calculation. So what did I tell you? Sometimes you might not have a proper knowledge or understanding as of now. Once you are done with this particular question, you'll be perfectly okay with it. So here in this question, what I am telling you, a company produces units with an average length of 10 centimeters. So they have given the average length. Mean length is given 10 centimeters and a standard deviation of 0.2 centimeters. They have already calculated the standard deviation by using the figures that they had. They have already calculated the standard deviation. What proportionate of the unit will have a length of? So in part A, what I am asking is, if I pick a maybe that particular pencil, let's assume this is the product is pencil. If I pick a pencil randomly, what's the chance of that pencil's length being more than 10 centimeters? Then you can find it by using the normal distribution. How to do it? Listen carefully. So you have to draw the bell curves for everything. The first one that I am drawing. The first one. Listen carefully. So my bell curve is like this. Okay. This is your mean point. In this question, what they are telling? Mean is how much? 10. 10 centimeters. What they are asking, if you pick a pencil randomly, now in this question, I am assuming my particular product as pencil. I am assuming like pencil. Okay. If you pick a pencil randomly, what's the chance of that pencil's length being more than 10 centimeters? So what I am asking in this particular question, this area, more than 10 centimeters. So more than 10 centimeters, I said you, it is symmetrical. Entire bell curve is 100%. It is symmetrical. So one side is how much? It is 50%. Then what's the answer for question A? The answer is 50%. The answer is 50%. Now let's move to the question B. Question B, what I am asking. What's the chance of a pencil's length being less than 10 centimeters? Less than. Then here again you have to draw the bell curve. Draw the bell curve. Okay. I'll draw it again. And mark your mean. Mean is 10 centimeters. Now what they are asking, less than 10 centimeters. Then less than 10 centimeters means this area. Less than 10 centimeters. Then how many percent is there? 50% is there. 50% or 0.5, whatever it is. Okay. And next one. Next one, what they are asking, what's the, if you pick a pencil randomly, what's the chance of that particular pencil's length being between 10 centimeters and 10.4 centimeters? How to do this particular calculation? Now you are going to get a proper learning. So let's first of all mark it and keep it. Okay. C. Draw the bell curve. Draw the bell curve. And mark your mean. 10. And they are asking between 10 and 10.4. So 0.4 means it's a higher value. It should be there in the right side. So I'll mark the 10.4 also. 10.4. So that's my x variable. That's my x variable. Okay. So what I have to find now, I have to find this particular area between 10 to 10.4. So to find this particular area between 10 to 10.4, what I should do? Very simple. You have to follow certain steps. First step is you have to find out something called z-score. How to find the z-score? Z equals x minus x bar divided by the standard deviation. Okay. So z is how much? Here x is 10.4. X bar is your mean. How much is that? 10 in the question they have given. And the standard deviation, how much is that? 0.2. Standard deviation is 0.2. Then here you are getting the z-score. So how much is the z-score that you are getting? 10.4 minus 10 divided by 0.2. You are getting a z-score of, you might say is 2, but it is not 2. You have to write it as 2.00. Always keep in your mind, very important thing that I am telling you, z-score should be written for 2 decimal places. It is a must, because when you are finding the figures from the normal distribution table, you can find the figures only if you have the figure or the z-score for 2 decimal places. So always you have to calculate the z-score for 2 decimal places. Then here we calculated something called z-score. Using this z-score, how to find the probability? Listen carefully. You have to go to your formula sheet. Okay. In your formula sheet, go to the normal distribution table. It is given in the formula sheet. You can get the formula sheet in your final exam. Standard normal distribution table. Okay. You see what's the figure that you have for 2.00. So I am finding 2.0 is here. So I need another one more 0. Then where is that? It is here. Then what's my number? It is 0.4772. Then for you all to get used to this particular table, I'll ask some numbers. Okay. If your z-score is 1.84, what's the number? 1.84. So 1.8 is here. 1.84. That means this particular column. Then 1.84. What's the number? 0.4671. I'm asking, okay, your z-score is maybe 1.63. What's the number? 1.63. So 1.6 is here. 1.63 only I have to find. 1.63. And what's the number? 0.4484. But in this question, what they are asking 2.00, then 2.0, and the remaining 0 is here. Then how much is that? 0.4772. Then here I'll write it 0.4772. What's the meaning of the 0.4772? It is 47.72%. 47.72%. The area between your mean value and the variable that you are finding, it is how much? 47.72%. So this is how you can find the probability. Again, you will get this if you practice only. So let's do another question. In this one, what they are asking? In this, they are asking between 10 and 9.8. Now you will understand this one perfectly. Believe me. 10 and 9.8. So first of all, you have to draw the bell curve. That's the proper way of learning. Draw the bell curve. Mark the mean 10. And you are going to find 10 and 9.8. So your variable is how much now? Now your variable is x is 9.8. X is 9.8. Then we have to find this area now. This area. You have to find this area. So z equals x minus x bar divided by the standard deviation. Then x value is how much now? 9.8 minus 10 divided by 0.2. Then 9.8 minus 10 divided by 0.2. I am getting a value of how much? I am getting a value of minus 1.00. Always take the z-score for 2 decimal places. Then what's the value you have for 1.00? So here you got a negative value, don't bother about that, okay. Here you got a positive value. Simply what is this positive and negative means? If your z-score is positive, you are finding the probability more than your mean. Now here see, your mean is 10, okay, and here you have the x value after 10. So you are finding the probability right side of your mean. If you are getting a negative value, you are finding the probability left side of your mean. That means less than the mean value, you have the x variable. Now here we are finding 9.8. That means it is there in the left side. That's why you are getting a negative value. So keep that in your mind. Very important. If you are getting a positive value for the z-score, it is there in the right side. If it is a negative value, if your z-score is a negative value, it's there in the left side. That means less than the mean value. Now here let's find the value, normal distribution value for 1.00. Then I have 1.0, another 0. Then what is that? 0.3413. 0.3413. Then what's the probability? It is 34.13%. 34.13%. Then if I pick a pencil randomly, what's the chance of that particular pencil's length being between 9.8 and 10 centimeters? It is 34.13%. And next what they ask? Next they are asking, if you pick a pencil randomly, what's the chance of that particular pencil's length being more than 10 centimeters? Now understand which part they are asking. So let me draw the bell curve. This is your part E of the question. Okay, I'll do it here. So the bell curve, mark the mean, x bar 10, x variable 10.4. What they are asking, more than 10.4 centimeters. Then they are asking this particular area. How to find it? Very simple. As of now, you might have got the answer also. You know, here we calculated from mean to right side, you have 50% completely. Okay. Out of that, from here to here, if it is 47.72, I am asking which part? I am asking this particular part. Then how to find it? How to find that particular part? 50% is this entire area. I said you, it is symmetrical. One side 50%, other side 50%. Then out of that, this particular area that we calculated between 10 and 10.4, we calculated it as 47.72%. So what's the answer that you are getting here? 50 minus 47.72%. I am getting a value of 2.28%. 2.28%. So same kind of question is there in the next one also. Your F, question F. What they are asking, what is less than 9.8 centimeters? Less than 9.8 centimeters. So let me draw the bell curve and mark the x bar, which is your mean, and let's mark the x variable, which is 9.8. So this time they are asking which part? This particular part. So we calculated, we know the left entire part is 50%. Out of that, we calculated between 9.8 and 10. What's the percentage? 34.13. 34.13. So if this part is 34.13, how much is the part that I have highlighted? 34.13%. Then 50 minus 34.13, I am getting a value of 15.87%. 15.87%.
I hope you got a clear understanding. I have done a video series for the subject management accounting in ACCA. you can purchase that particular subject through the link available in the description. In that particular video series, I have done the entire syllabus and I have practiced certain questions and I have given you certain tips to pass the subject management accounting in one go.